All right, so they like you, as I said, to use this word trade-off, the trade-off between the level of confidence and the width, and we've talked about that. What's the difference? Higher level of confidence, wider the interval, so that we can be sure or surer to capture that true proportion. So there is that trade-off. And so you can see there, if you have a lower level of confidence, the less time or less opportunity you're going to in capturing that true proportion. So we've got to weigh that up, I guess. Now, in some questions, they want you to solve for n. How many should be in the sample to make sure I don't exceed this certain margin of error at a given level of confidence? And so that's what we're going to have a look at right now. So how do we find n? Well, I said to you before, we can rearrange this equation. So here's an algebraic question for you to do. Rearrange this equation, transposition, so that it gives me n equals. Go. Okay, so first, easiest thing to do first is to divide by z. You can square both sides if you wanted to, but you've got to make sure you square z as well. So it's easier to divide by z first.
Is that what you didn't do, square first? Well, I just subbed in like p equals 56 over n, and then I was trying to isolate n.
Right, no, just in general. Yeah. Just in general, isolating n. Now we can square both sides. So e on z. So e gets squared and so does z. And we do that to undo everything, to get rid of that square root sign. Then what do? What's next? Yeah, get n to the other side. So multiply both sides by n. Multiply both sides by z squared. Or we could even cross multiply, however you want to look at it. Either way, that's the next step. Well, there's a couple of steps combined there. And the last thing to finish off is what? Divide by e squared. And that's it. So some people like to write this formula as well in their notes, as well as the margin of error one, because then you don't have to think about rearranging. So if you're solving for n and you have to do it manually, then you've got that there. You will notice it's in the E activity already anyway. So the one where it says sample n for CI, there it is there. Z squared P, 1 take P on E squared. So if you ever forget it or if you ever need it, as long as it's in the calc section, then you've got it there anyway. So it's handy to have that rearranged. So this one is obviously your margin of error one. And if you're solving for n, so that equation or this one, if you're solving for n. And we've just rearranged that algebraically. The reason why I made you do that is because you could get a problem where it's in the non-calc, you've got some reasonable numbers, and it wants you to just show something in terms of n or in terms of e or whatever it might be. So you should be able to manipulate by sticking a few numbers in, but you might not have all the figures. And they'll come up in the questions that we do later. All right, so choosing the sample size. I'll let you read this question. Now, I don't like it like how it's written here. Find n if the magnitude is 0.1. It should not exceed 0.1, the margin of error. Usually we talk about not exceeding a certain error. That's the assumption we're going to make. So what are we actually trying to find here in this question? I guess choosing the sample size in the title gives it away. We're trying to find n, the number in the sample, at the 99% level of confidence, such that we do not exceed a margin of error of 0.1. Solve for n, 3 of them, 3 solutions, but the one that we want, it does say something somewhere about n greater than or equal to 100. So that's our n value, but I need to talk about that n value. We don't say 153.69, we actually say 154. I want you to think about, your homework is to think about why we say 154, not 153. And even if that was 153.1, we would still say 154. So homework, and think about why. And we'll come back and finish that off tomorrow.